I want to talk a little bit about essentially product design and version control. So that's mostly what the talk is about today. I'll also do some fun Git stuff for those of you who use Git. Who uses Git? Who's heard of Git before? There's a couple people. There's a person in the back there. Actually, you know what I want to know? Sorry, I don't usually like to do sort of ask the audience things, but I am a little bit curious. How many of you, raise your hand if you've used something other than Git? Okay, that's about 50%. I more and more, so when I started my career, so I'm one of the GitHub co-founders, and a lot of what I did at the beginning of GitHub was try to sell people on using Git because nobody was using Git at the time. And it's kind of fascinating now that I'm so old that there's a whole generation of programmers. I'll give talks to entire groups of people that have never used anything other than Git, which is sort of an interesting place to be. So what I want to talk about today is about product design, but sort of from the aspect of version control, and maybe give you a couple of tips about asking your code in Git if there's some of these commands that you don't know. So I have a long background in version control. It's one of the things that I love, that I'm fascinated with, that I find very interesting, and I feel like not that many people find version control interesting. And so I want to talk about it a bit because I think it's fascinating. So my background is I was one of the co-founders of GitHub. We started GitHub in 2008. So I've been working professionally I've found version control interesting for at least 15 years. I wrote a book called Pro Git. Some of you may have read this book without paying for it because it's free and open source. It's on gitsem.com. So if you go to the official Git website, this is essentially all of the official documentation of Git, and it's open source. And now I'm working on a new Git client because I can't stop working on Git stuff. That's just, it's always interesting to me, and I can't escape it. But what I want to talk about a little bit is about product design and some of the things that we learned about how to design products at GitHub and apply them to modern version control systems and get an idea of, like, I'm going to talk about what I'm doing because I'm writing a new sort of version control client, and talk about what I found interesting pulling stuff from GitHub, from what I learned at GitHub, to what I'm building now. But I think generally you can kind of generalize a lot of what I'm talking about to any product that you're working on, and that's what I find interesting of sort of these patterns of how to design good product, how to build good product. So the main thing that I want to talk about for the beginning of this is something that GitHub used all of the time, and that I feel like not enough people use when they're trying to work on software, when they're trying to build product, when they're trying to figure out, how do I make something that people love? How do I make something that's interesting, that solves people's real problems? And the best tool that we ever used at GitHub, and that I've used everywhere that I've done 2 startups since GitHub, but we use this constantly, and I feel like not enough people use this, is the concept of first principles. So if you're unfamiliar with the concept of first principles is a physics sort of phrase that means a basic concept or assumption that we know to be true that's not deduced from anything else. So it's sort of a basic underlying assumption of something that you know, right? And the number one tool that is the most useful is the word why, right? To try to figure out what a first principle is from anything, and it can be a product thing, which is what I'm going to talk about today, but it can be pretty much anything in life, right? And if does anybody have children? Who has a 3-year-old or a kid around 3 years old? There's a handful of people. So you'll be very familiar with this word, right? Because the 3-year-old's favorite word in the world is why. because they don't know anything. They're trying to get to first principles on everything, right? Anything they learn is essentially a first principle to them because they have no assumptions. They don't know a lot about the world, and so they want to know about the world, and so they ask this question. And so it's a very useful thing to be able to continue to use, because as you get older, as you become an adult, as you gain more knowledge in the world, you have more assumptions. You have more assumptions about how something works or how something should work, right? And so you stop asking why at a relatively young age, right? And much earlier than before. But I want to tell you why this is interesting, and I want to use a story that I heard. This is a story that one of my favorite storytellers in my life that I've heard tell stories is a physicist called Richard Feynman. So I don't know if you know. Right now, it's really cool. Like Oppenheimer is the cool physicist now, but when I was a kid, it was Richard Feynman that I really liked, and he tells this story about how to come to sort of the something interesting about anything in life. And he tells this story about his Aunt Minnie, right? Or I mean, it's a made-up one, but the idea is, if you have an Aunt Minnie and somebody, your grandma or whatever, says, hey, Aunt Minnie's in the hospital, you can say, okay, you can take that at face value, or you can say why, right? Most of you would probably say why. If somebody came up and said, hey, Aunt Minnie's in the hospital, you'd say why, right? Like, because you don't have assumptions. There's assumptions you can't deduce at that point. Is it serious? Is Aunt Minnie going to die? Why is Aunt Minnie in the hospital? And so you say why. And it says, okay, she fell and she broke her hip. And you're like, okay, you could stop there. That's fine. It's not serious. She's probably not going to die. But what if you keep going, right? You can say, okay, why? Why did she fall and break her hip? Well, she slipped on some ice. Okay, well, that's very specific. Now you know that it's not because Aunt Minnie got too drunk and she was out too late with her friends and, she fell. She was doing something. She was on some ice and she slipped and she broke her hip. But now you know, most people would probably stop at that point. It's not interesting after that point, right? You have all the information you probably need to know. There's all of these assumptions, actually, that happen at this point where it's like there's no further reason to keep asking why. If you're 3 years old, though, you might keep asking why. And so let's keep doing this, because when you explain a why, you have to be in some framework where you allow something to be true, right? And so part of the of how to get interesting information about how to build product or how to find things in the world interesting is to try to make yourself not allow things to be true, right? Because there's lots of times that we do this when we build products. So let's keep going and keep seeing where this leads, right? So if you say why at this point, why did she fall and slip on ice? What would you say? Right? You would say, well, that's kind of a dumb question, but she fell and she slipped on ice because ice is slippery. Now it's almost like you're dumb for asking this question, because you should have assumptions that stop you from asking this next why. But what if you don't, right? And now, if you ask why again, why is ice slippery? How many of you know why ice is slippery? Right? Like, ice is slippery. There's one person that's raising their hands. I'm going to bring you up to explain it. But it's actually a very, very hard question to answer, right? It's actually almost an unanswerable question if you get far enough down into the physics of why ice is slippery. Not very many people know why ice is slippery. It's very interesting because it's a solid. There's almost no other slippery solids, right? If you're standing on very, very smooth concrete, it's not slippery. But if you stand on very smooth ice, or any ice really, it becomes slippery. Almost any other solid has to have some viscosity. It has to have some water or some grease or some oil or something on it to be slippery, right? The solid itself is not slippery, but ice is slippery. And so I looked up on the internet. I just Googled why is ice slippery and tried to find. This was a paper that was published last year, right? And in the abstract, it says the origin of ice slipperiness has been a matter of great controversy for 100 years, right? For a decade, nobody really knows. An atomistic understanding of ice friction is still lacking. Nobody really knows why ice is slippery. Water is one of the only elements. Not elements. Water is one of the only things where when you freeze it, it expands, right? Almost everything else, when you make it cold, it gets smaller. But when you freeze ice, it expands. And so actually, when you put pressure on it, it creates a water surface on it, because it very quickly turns back into a liquid form, and almost no other solid does that. And so if you ask why, if you try to get to first principles, what you start out with is something that's very basic, right? Aunt Minnie's in the hospital, and you ask why a couple of times, and you get to, the unsolvable problem of an atomistic understanding of ice friction, right? And I find this interesting. You can do this to anything. You can take any product, any feature that you're working on right now, and sit down with your team and say, why? Why? Why are we doing this? What are we trying to accomplish? What are we really trying to do with this? Are we stopping at the wrong point? Are we taking things that we're making assumptions to be true? This is how it should be done. This is how our users expect it to be done. And you're stopping too early, right? Like, keep going down, get down to the first principles of what it is that you're trying to solve, what it is that you're trying to do in the product that you're building or the feature that you're building, and then build back up something that's more interesting that can solve that first principle in a better manner than any of your competitors or anything else that's out there that's on the market. So what I want to do as a more specific version of this is talk about this from the point of view of kind of the product that I'm working on, but a product that all of you use all the time, which is version control. So what are the first principles of version control? This is just an example, but I find it interesting. So we all use Git. Everybody in this room uses Git. This wasn't true, as I said, 15 years ago when I started doing talks like this, but it is true today, I think. But why? Why do we all use Git? Well, one could argue we use Git because we need version control, and it's the most ubiquitous version control system, right? And so it'd be kind of dumb to use other version control systems because other people wouldn't be using it, or you'd have, some people use, I don't know, Pujol or Darks or whatever, but like most people use Git. But we use it because we need version control. So why? Why do we need version control? We need version control to collaborate with each other, and we need it to save our work. I think it's relatively clear. We've all been doing that for a really long time. But why? Why do we need a version control system in order to do that? And there's a couple reasons, right? Like, I'm saying two things here, but like, A, our computer doesn't save the history of our files. Like, that's one of the reasons that we need to be able to save our work. And we need to let other people access those files, because if you have a file on your local disk, it's not very easy for somebody else to access that file. And there's good reasons for both of these things. But why is that, right? Why are these things true? Like, why does the disks, file systems that we use not save every version of every file that we're editing, right? There are file systems that have been created that do this type of thing, but they're not widely used, right? It wastes space, or there are problems with them. But like, why is that? Because what's interesting about this, if you think about this from a first principles perspective, that version control is for history saving and file access, is that that's not the only way that we do these things. For instance, if you have a Chromebook and you're writing a document in Google Docs, right? Neither of these things are problems. If you're writing a document in VS Code on a Mac or something, both of these things are problems, so you need a version control system. If you're using Google Docs, neither of these things are problems. But you're still writing a document, you're still editing text somewhere, right? The fundamental thing that you're trying to accomplish is not that much different. The version control, you can do both of these things, but you're not doing them explicitly, because you can take a URL and you can send it to somebody and they can access your file in a way you can't do on disk. Or you're never committing. You're not in Google Docs. You never commit a Google Doc, right? It just saves your work all of the time. So it's doing the same things that version control does, but without you even knowing really that you're using there's not a version control system that externally that you have to use in order to accomplish those things. So the question then becomes, why does Git not do Google Docs type stuff, right? Or why are the version control systems that we're using not doing the things that Google Docs are using? Why is there not a new version control system that kind of takes the best of the interesting things that some of the systems that we're using to edit files and collaborate on files are doing, and bring them into the worlds that we live in of doing software engineering? So I want to ask, what does version control do, right? Like, what are all of the things that version control does? And this is actually kind of funny, because if you think about a lot of different products, and you say, what does it do? A lot of times it's relatively straightforward. But actually, version control system does a lot of different things in our world, right? And a lot of them are basically orthogonal, right? They don't really have to do with each other, but all of them are kind of contained in Git or in Subversion or something. So it backs up our work, so it saves sort of the work that we're doing, which is, commands like commit in Git. It allows us to experiment, so we can do different sort of branches and we can work on different branches at the same time without having. So this is something that like Google Docs can't do, right? It can save and back up our work, but it's very hard to experiment on stuff in something like that. We use it for collaborating and reviewing, so sharing work with people and giving feedback on stuff, so doing like the sort of diff and the merge commands. We use it for moving bits. So if you've ever used like Heroku or something, right? Like it's not any of these other things. It's just taking code that's on your machine and putting it on another machine so that you're not having to use FTP or something like that. So push and pull. And then we also use it for archeology, which is, again, completely orthogonal to any of these other things, right? We're using all of these other things to sort of create this history, but then we have these archaeological tools that let us go through our code and answer questions about our code. But all of these could be separate tools, right? They could be completely separate tools that are uniquely. The only thing that all of these have in common is that there's a shared database, right? There's not really a massive difference between sort of reporting tools and ORM tools. The thing that they have in common is that they can both talk to a Postgres database or something. So it's interesting to me that we don't have more specific tooling around each of these things to help us out in a way that we as modern software developers work. What we do is we kind of wrap it around the tools that were written for Linux kernel developers 15 years ago, 20 years ago. So what I want to do, just to dig into one of these as an example, and again, because I think it's interesting to look, this is, again, what I'm kind of looking at and what's interesting to me in the product that I'm working on, but this type of questioning of going down to first principles and then asking, how should I think about how to make this better for what I'm building, I think is generally applicable. So I want to talk about archeology. This is not something that I'm actively working on the Git Butler product, but I find it very interesting of what should our archaeological tools in a version control system, or just in general, what should our code archaeological tools be? How should we think about them? And what I want to talk about is another thing that I think is a really useful question to be able to decide what to build, right? If you've gone down to first principles and you've decided, okay, this is what my product should be doing, when you build it, I think the most interesting thing that you can ask yourself or you can ask your team when you're looking at a feature or you're looking at something that you're trying to build is saying, what question does this answer? Because what it does is it helps put you in the user's perspective. But I think what happens most of the time with software engineers is that we say, what can we do, right? Rather than what from the users, you think about it from the programming and the data perspective, what is it that we can do? And you'll say, we'll just expose that and we'll give them some CRUD tools or whatever, and they can eventually get there and they can solve the problems. They have the tools to solve the problems. As opposed to thinking of it from the user's perspective of what question does this feature answer, right? What question does the user have? What problem are they trying to solve at this point? And are we answering that question? Are we solving that problem the best possible way? And I like asking this when we're doing feature design because I think it's really interesting. It's a great way of putting yourself in the user's perspective and trying to think from a user's perspective and say, what are we really trying to do? So from an archaeological standpoint, I want to ask, I'm going to break them up into a couple different sections. One is the common questions. So the common questions that we will ask and have answered by Git, let's say, is this question, which I think is actually a very stupid question, but it's the question that we have answered the most, right? Because the answer to this question is the output of git log. What are the last few dozen commits that have been made to this code base? Like, what was the last time that you ever actually asked that question, right? Like, you really wanted this question to be answered. Like, I think it's very rare. This is not a very useful question to answer, but this is the most common question that we have answered in our code base because it's what git log gives us. So if you run git log, you get something like this, right? And you're like, okay, here's a bunch of commits. That's great, but that's not really answering a particularly good question. If you say, dash dash log dash dash one line or whatever, or dash dash graph dash dash one line, you get something that looks like this, or you can use a GUI. Most GUIs will give you something that looks like this, which I find this to be one of the most useless things in the history of version control. Like I really this doesn't answer any question, and I'll tell you why. What this is a subway map, right? And if you think about a subway map is particularly and specifically bad at answering any question that you need to answer when you're using the subway, right? Because when you want to use the subway, what are you asking? Like, what is the question you actually have? The question is generally, I know where I am, and I know where I want to go, and I know I want to use the subway, right? And you have way too much information to answer that question, and it's actually relatively difficult to use a subway map to, like, they're very pretty, and this is very pretty. I mean, kind of. Depends on your aesthetic, I suppose. But, it's pretty-ish. It's interesting looking. But like a subway map is not a very useful tool. And I feel like GitLog is not a very useful tool in the same way. Because what you really want is you want Google Maps, right? You want something that knows where you are and where you want to go and what the subway information is, and will just give you the one line and the one timing and the pricing that just gets you from A to B and helps you use the subway. A subway map does not help you use the subway very well. Even if you get on the subway, it'll only show you the one line that you're getting on at that destination and where you are and where it goes from there, right? And so it'll always give you some subset of this. And you can do this in Git, but it's a little bit more difficult, and most people probably statistically don't actually know how to do it. The other common question that you can answer with Git is, who is the last person who touched this line of code, right? So you can run git blame. I don't know how many people have used git blame a lot. I actually find, I haven't done a lot of Git talks in a while, and I found that people are getting worse and worse at Git, and it's mostly my fault because more people are relying on GitHub to give them information out of their Git code bases rather than actually knowing how to run commands in Git. But you can run a command called git blame, which will go through and try to figure out who was the last person to touch any particular line of code. And I don't know if you know this, but you can give it a line number. You can even give it the name of a function. There's a way to give it a name of a function as a regex, and it will say, okay, this is what I think the function is, and it'll just limit it to that. But in this case, I'm looking at a class in a TypeScript thing. And it'll say, okay, I'll look through the history of every commit that's ever touched this file, and I'll tell you who the last person to edit that file and what the commit was. So you're like, okay, well, that's kind of useful. This is kind of ownership, right? But that's not really the question that you're asking. Like the question, what the answer that you want is, who's responsible for this class, or who do I ask about? If I need to do something to this, who's the owner of this? Who's responsible for this? Who sort of logically, who should I be talking to if I want to do something to this? This can give you that information, but that's not really the question that it's answering, right? The question. Also, just as a quick tip, if you say git log -L, capital L, and give it a line range in a particular file, it will give you a log that's limited to just the changes to those particular lines. So you can kind of see stepwise. It's almost the same information. It just gives you it in a log format. So it says sort of, this is the last change, and then the change before that was this, and then the change before that was this, and you kind of have the commit messages and stuff as well. This is actually a pretty useful command, but I have to assume probably nobody in this audience has ever run this before, but it's pretty cool. All right, but it gives you the same information. So these are the common questions, but again, I don't think they're particularly useful ones. And so what's interesting to me is that we ask questions that our tools make easy, and we just don't ask questions that our tools make difficult, right? For the most part, we just try to kind of work around it. So here's some uncommon questions that I think are much more useful, and you can answer in Git, but people tend not to because they don't know how to actually answer them. But it is answerable in Git. So This is probably the most commonly useful one and the one that GitHub answers for you most of the time. Because if you push to a branch and you open a pull request, this is really what you want to know. What commits are on this branch that are not yet merged into a target branch, into origin master or something. And you can do this on the command line. You can run, so let's say that this is what our sort of history looks like. We kind of have main on one side and the self-hosted branch on the other side. And there's 3 commits on one and 5 commits on the other, and they're not merged yet. So you can run this double dot syntax, git log main ... self-hosted, and it'll say what commits are reachable by this one branch that's not reachable on this other branch. And you can do that with any 2 branches. And this will essentially give you these 3, right? It'll give you the ones. So when you go to a pull request, this is essentially what GitHub is running and just saying, okay, here's what's reachable by this branch that's not on the other branch. And that's a much more interesting question. That's the one that we mostly want to ask, but it's actually relatively obscure to answer with Git by itself. You can also use this syntax, which I tend to use because it's easier for me to remember which goes on which side, which you say git log some branch, you say what's on main that's not on self-hosted. And I like thinking of the caret as a not. It's easier for me to remember. And so that'll give you the opposite of this, right? Or, I mean, it's the same thing. What's on one branch that's not on the other branch? Another common question that I think is more valuable, what commits introduced the change that included a specific string, right? So a lot of times you're like, I remember that I wrote something in this function or whatever. I remember what the string is. What commit was it? When was it? And so there's this thing called pickaxe. So if you say git log dash capital X or capital S, or you can also do capital G, you can give it a regex as well. And it'll say, okay, here's any commit where any of the changes that were introduced or removed in that commit has this regex or this specific string in it, and it will just limit the log output to the commits that introduce or remove something that has that string in it. And I find this very valuable, but this is something that very few people can do because most people don't know that this is even an option, and GitHub doesn't allow you to do it. And so things that GitHub doesn't have tooling for, people tend not to do. But I find it very valuable. Another was, what file was this function moved from? This is actually a relatively difficult question to answer. And actually, raise your hand if you know how to do that with git blame, to have it follow renames and file movement. Okay, so this is really valuable. So it turns out this blame command, it says, you know, Kirill is essentially responsible for this function. But in reality, most of this code was moved to this file by Kirill, right? He moved it from some other file into this file, but that last commit was his, and so everything looks like it was his. Or if you do a big white space change or whatever, it looks like every change to every line was yours. But git blame, you can give it some options to make it ignore this. So you can say git -w says ignore white space changes, and it will just ignore anything that's a white space change. And then this is my favorite Git option, which is -C. If you do it one time, it looks for movement within a file. If you do it 2 times, literally the same option two different times, it does movements between files in one commit. If you do it 3 times, it does movements between different commits in a history, right? So it becomes more and more expensive computationally because it has to look into all these trees and calculate all these diffs. But it turns out that this TypeScript class was just moved around a lot, right? It was at some, so it looks like it was all Kirill, but it turns out it was mostly Matthias and Nikita and me, and Kirill only has really 1 line in this, right? Like and it's relatively minimal. So if I want to go ask somebody about this, it's probably not really Kirill. He was just the person that refactored this code into another file. But this is a much more valuable question, or I should say a much more valuable answer to the same question, right? But the problem with Git really is that since so few people really know how to do this, like how many people know that you have to do 3 capital C's in order to get this type of computation, right? It's very, very rare that nobody asks this question because very few people know how to answer this question. And then the last of sort of the uncommon questions, I find this really valuable as well. What files are most closely related to this file? So let's say if I'm in a file and I want to know, let's say, you know, for this file, what other files tended to be touched in the same commits, right? I find that actually a very interesting question, because now I can get an idea of what files are sort of related to each other, what files I should also be looking at if there's a bug in this file or something. There's no way of doing this in Git, but you can write a script, right? If you want to actually really get fancy with Git, you can write a script. So here's a dumb shell script that I wrote, and it basically does a log and sort of shows the content of all of the files that are in each one, and then sorts them and just shows you the top 5. So I can run this script on one particular file, and it says, the virtual branches mod.rs was modified in 9 commits in the same commits as this types.ts, and so it gives me this idea of like these are related to each other, right? And then lastly, I want to talk about the impossible questions. So there's questions I would love to ask about my code that you can't ask about your code because Git has no access to this data. One is, and this is the most important question, especially in a modern sort of GitHub-centered workflow, which is if you run a blame and you look at a line and there was a commit or whatever, what you really want to know, what I think is the most valuable thing if you're using this pull request-centric workflow, is what pull requests contributed to this file. Because I want to know these conversations and that tells you why the file was modified this way, or how the file came to be in this manner, what the reasoning was behind it. But actually in GitHub with pull requests, none of that data is in Git, right? So Git can't answer any of those questions, and GitHub is not very good at answering any of those questions. Like GitHub's own blame command doesn't do this, or doesn't even link commits back to the pull request that they were included in at some point. And so, but this would be a much more valuable question of saying, if I'm looking at this function, tell me the pull request that modified this function so that I can go back and get an idea of how it came to be this way. But it's almost impossible to do. Like the metadata in GitHub doesn't really give you the tooling to do this very well. What code and other repositories are related to this code, right? Like doing sort of cross-repository questions is very difficult. What were the conversations that my team had around this code before it was changed? How valuable would that be to say, like, okay, I'm interested in this function. Tell me a story about this function. Tell me the conversations that we had. Tell me the tickets that we were working on when this was edited. What was I talking to my other coworkers about when this happened, right? But nothing has this data. What did the authors reference when writing this? Like, were they looking at ChatGPT stuff? Were they, what were they Googling? What were the websites what was the Stack Overflow thread that they were going through, or whatever, that they pulled some example out of in order to do this? Like, what is the reference behind this? What specifications is it based on? What tickets was it based on? What errors were commonly created by this code, right? Like, what happened if I modified this and errors stopped, or I modified this and errors started? Like, can we get sentry data to be related to a function there's so much that we can't access, right? That would be massively valuable if we had this data when we were refactoring code or when we were editing code, and we don't have any of this. And I find it a lack of imagination of version control systems that we don't have any of this data, and we just don't care. And I feel like we should question it more. We should be more frustrated with the tooling that we have around version control, because it's so much of the work that we do, and it's so valuable, and we have not changed these systems for, 15 years in the case of Git. But if you think about the real difference between what our workflows are and what we're using version control for, is it massively that much different than RCS, right? Than SVN, than Subversion? Like, is it really that much different than the systems that came before that? And I don't think that the answer is yes. So I'm going to end. I do want to say that what I'd really like to have with everybody in this room is a conversation about these things. I think it's more valuable for us to have a beer and talk about this stuff. So if you have ideas about this, please join us. We're having an after party across the street over here. Come have a beer. It's on me. Tell me what frustrates you, what you want to ask your code, what you would love a version control system to look like, because I think if we're all sort of frustrated in the same ways, then we can demand better tooling for not wasting time and just being able to work on interesting problems. So, what do you want to ask your code? I would love to know. Thank you very much. And beers across the street. Thank you.